Okay, so quiz 11 is one of the quizzes which probably has the least math in it. But anyway, we're looking at, just moving on to question A. So he asked you first for the degrees of freedom for the test statistic. The test statistic is F. So basically we're trying to see if our regression model is appropriate or not. That's what we're doing in this whole part A. But the first thing, remember with an F table, there are 2 degrees of freedom you have to worry about. So he should have put degrees, well, I think the degrees of, I don't think you can make that more plural. But remember that you need 2 of them. You need f of n, and then n minus k minus 1. No, that's not right. Sorry. K, and then n minus k minus 1. So that's why you would get your 2 degrees of freedom would be f at k, which is 3, which are your number of predictors, and then n minus k minus 1, which would be 34 minus 3 minus 1. So your 2 degrees of freedom are 3 and 30. Right? So that's the way this is written. It means your f-score at 3 degrees of freedom and 30 degrees of freedom. So when you go and look that up on your f chart, you find that the smallest f value at which it would be significant, aka 0.05, is 2.9223. So that's the answer to the second box in part A. And the third question, if f is 17.1, so it's super high, so it's way above what the minimum would be in order for it to be significant. So we say that yes, that the data is statistically significant. Part B, correlations, causation, anything like that. Frankly, I don't know how the professor hasn't gotten sick of saying it, because I pretty much already am. But so yeah, you can't say, like, it's not proof. You can't support the claim that the guy made. Part C, so he tells you that you're testing for, you basically want to see if above average drinking affects how many reports you produce. So the null hypothesis, as always, is that there is no difference, ergo that there's no relationship and that the values are the same. So then the p-value, he gives you a really useful hint here. He says, if 5 people were chosen at random from 34, what is the chance? So basically, this goes back to probability that we learned way early on. So it would just be 11 over 35 times 10 over 34 times 9 over 33 times 8 over 32 times 7 over 31. So you multiply that out and you get, sorry, you only have 34 people. So you use 34, 33, 32, 31, and 30. So you multiply that out, you get the p-value is equal to 0.0017. So then the last box says, is it statistically significant? Well, we know that p is less than 0.05, so it is statistically significant. Sorry about that.